Good day, viewers, again, my beautiful students, my handsome students, my intelligent students. This is part 3 of our videos, and this one is also going to be on gas law. But in this case, it's called general gas law or general gas equation. So as I always appeal to you, do the best you can, get a sheet of paper, a biro, and try to jot down some. Don't just be looking at it or snub it, ignore it, say a day to resumption. That's when you go through this thing. These topics are very, very important, especially for your second term. But those are areas you are going to encounter. Second term is very short. You need to acquaint yourself with all this knowledge, so you don't create problem for any teacher that's taking you in your various schools. Thank you. So the topic is general gas law. Remember, I told you I program questions on all of them. By understanding the question, you definitely understand the topic. Give the general gas equation. General gas equation, remember, is a combination of both Boyle's law and Charles' law as far as chemistry is concerned. All those pressure law, those are areas of physics. So Boyle's law and Charles' law, the combination gives the general gas equation. So for example, Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure if temperature is constant. Then Charles' law says that the volume of a given mass of gas is directly proportional to its absolute temperature if pressure is constant. So you look at the two of them. It's not just like joint variation. It's actually joint variation. You add the two together. You have volume is here, volume is here. You can volume, pick one. Volume varies as T over P. You see it. You have placed this one on top. Then make it, remove the proportionality, introduce proportionality constant by removing this variation sign. So you have V equals KT over P. You see it. Now become PV equals KT. PV over T equals K. So this is shortened form of it. But when you have initial volume at pressure, initial volume V1 at pressure P1 and temperature T1, where it now becomes P1 V1 over T1 equals constant. Similarly, let me put this, P2 V2 over T2 at temperature constant. So both of them are equal to constant. Therefore, becomes P1 V1 over T1, P2 V2 over T2. So this is the general gas equation. So you memorize it. P1 V1 over T1 equals P2 V2 over T2. This is how it was derived, where P1 is initial pressure, V1 initial volume, T1 initial temperature, P2 final pressure, V2 final volume, T2 final temperature. So that is how it was derived. If you have taken this, we delete it. So generally, give the general gas equation. You don't need to prove it. You just need to say P1 V1 over T1, P2 V2 over T2, where you define the various terms. That's what they want from you, not to be proving it. Nobody asks you to prove. Nobody asks you to derive it, just to state it. That's all. Then tell them what V1 P1 means. So the second question, number 2. If the volume of a given mass of gas is 298 Kelvin and pressure of this meter pressure is 2.12 dm3, calculate the rest. So what you do, just state it. P1 V1 over T1, P2 V2 over T2, where P1 V1 T1 P2 V2 T2. Just understand the basic principle and you'll be able to solve it easily. He said if the volume of a given mass of gas is 298 Kelvin, if the volume of a given mass of gas is 298 Kelvin, so 298 Kelvin, that's the temperature in Kelvin, and pressure of 205.2, pressure 205.2 times 10 to the power of 3. That's unit. Remember, as you are writing it, as you are reading it, so you write it together before you get to full stop. Everything that comes together falls into one group. P1 V1 T1 or P2 V2 T2. No breaking. Is 2.12 dm cube. You can leave it in dm cube because that's the unit they gave us. So you see that This one now stop here. Now stop here. Look at it again. Go over it. Try to follow it properly. Even if you are not too good in chemistry, the way I'm putting it, you should be able to understand it very well. It's like a classroom environment. That's why I'm stressing it. The little trick in it, I'm trying to expose all of them to you. And that's why you have to play your part by helping to subscribe and share it. And God will richly bless you. If the volume of a given mass of gas at this 298 and pressure is still continuous of 205.2 times 10 to the power of 3 is 2.12 GMQ. So you stop there. The next question. Calculate the volume of the gas at STP. That's another question. Remember, STP means standard temperature and pressure. STP, standard temperature and pressure. At this temperature and pressure, the values are fixed. They will always give you. They don't give you, it means they know you know it already. So, calculate the volume of the gas at STP. And they told you at STP, standard temperature, standard pressure is 101.3. 101.3 times 10 to the power minus 3. Remember, calculate the volume. You don't know this. Standard temperature is 273 Kelvin. 273 Kelvin. But I've got all the values you want. All you need to do is to substitute. You say substitute. You have P1 205.2 times 10 to the power of 3. V1 2.12 dm cube. T1 298 Kelvin. Remove this dm cube. We'll call it later. Equals P2, because you put all the unit, we model everything up, make it rough. P2, you have 101.3 times 10 to the power minus 3. Well, you know that both of them have the same unit, so they cancel out. N minus 2, is that not what the root? And so definitely, these two will always cancel out, so don't have the problem with units. Times P2, V2 we don't know, over T2, 273. Kelvin will also cancel Kelvin, so no need to put it. It will make your work look rough. So make it the sort of formula. First of all, straighten it first. 205.2 times 10 to the power of 3 times 2.12 equals 298. Sorry. Times 273 equals 298 times 101.3 times 10 to the power of minus 3 times V2. You now say, therefore, V2 equals 205. Make it the subject of formula. You must follow the processes. Don't jump any stage. You will lose mark for it. 205.2 times 10 to the power of 3 times 2.12 times 273 over 298 times 101.3 times 10 to the power of 3. That's what we have. 10 to the power of 3, we first of all cancel 10 to the power of 3. So V2, now I can do the rest once. Let's see what we have. 205. I hope we got it right. 205, good. 205 times 205.2 times, what am I writing? 205.2 times 2.12 times 273. Okay, give you, divide by 298 give you, divide by 101.3 101.3. Final answer is 3.934. 3.934. Give you 3.93. 3 singular figures or 2 decimal places. DMQ. Remember, their question is on, the value is on DMQ. We also look the final volume on DMQ. So that's how we carry out this calculation that involves general gas equation. But remember, we are using this one because they gave us standard temperature and pressure. At times, they may not give it to us as standard temperature, they just give it to us normally. So we'll use it normally. And because they gave it this one to us, use it like that. And again, the one of Kelvin, they may mix it up. They put some as degrees Celsius, they may put this first one as degrees Celsius, while the last one as Kelvin. In which case, you must convert that degrees Celsius to Kelvin first. All temperature unit must be on Kelvin, because that's the standard SI unit of measurement. Thank you very much. God bless you. Please do well to subscribe, share, and also press the like button. God bless you.